Hello everyone, hello my dear attendees. I'm Anton Boyko from Ukraine. I'm Microsoft Azure MVP, and today I want to talk with you about storage and database options in Azure for Node.js apps. So let's get started. Today we will talk about Azure Storage, and Azure Storage, as you may understand from the title, it's storage in the cloud. This storage is scalable, durable, and also available. And basically, you can access this storage from every point and every platform because this storage service exposed via RESTful APIs, via REST API to the outside world. And when we talk about storage, we need to understand these four abstractions. The first one is blobs. As you may understand from the title, blob stands for storing like a big amount of unstructured binary data. The second one, called drives. The main idea of drives is to provide you with something like NTFS file system for your virtual machine. We will not take in more details with drive during current session. Tables. The main idea of tables is that provide you a kind of key-value storage mechanism. You can store your structured data. It's not kind of relational database. It's just, as I said, a key-value storage for structured data. And the last one, called queues. The main idea of queues is that they can provide you a mechanism how you can send messages or tasks from one module to another. So let's start from blob storage. When we talk about blob storage, we always will have this kind of structure. So the first element in our structure called account. So it's like Azure Storage Account. In this example, we name it Contosa. The next one is container. The main idea of container is the same like folder on your file system. So you can consider these containers as regular folders on your regular laptop, for example. The next element in this structure called blob. So blob is just a binary array of some data. It can be text file, it can be video file, it can be image, audio, it can be really anything. You just need to know, for example, when you work with this blob, you work with kind of text or audio or video. So it just depends on your application needs. And the last element in this infrastructure, it's called pages or blocks. Basically, we have two different types of blobs, like page blobs and block blobs, but we will talk about this later during this session. So for now, let's just say that we have blob, and each blob consists of pages or blocks. And of course, you can easily access each blob if you have required permissions using this simple URL. And you have your account name here, and then you have a regular domain name like blob.core.windows.net. Then your container name goes here, and then your blob name goes here. So you can easily create this URL even without calling Azure Blob service if you know an appropriate account name, container name, and blob name. And of course, if you have required permissions, you will be able to access this blob using this URL. So let's step further. We can perform these main operations on our blob storage. Put blob, it's very simple operation, it's just the same like upload our blob. The next one, get blob, is the same like download. Delete is delete, of course. And copy. Copy is a very interesting stuff because Azure Blob Storage provides us with kind of server-side copy option. In case we want to use server-side copy for our blob, we can just provide, for example, like source blob name and destination blob name, and we do not need to download our source and upload our source to our new destination, because it will have like a huge impact on our traffic and so on and so on. So that's why we can say, Azure, please create a server-side copy. And of course, you will obtain a lot of benefits. The first one is, as I told you, you do not need to upload and download all this stuff to create this copy. And the second one is about speed. I can give a real example from my personal experience. I host a lot of Azure trainings here in Ukraine, and for each Azure training I ask all attendees to register an Azure subscription. And when they came with this Azure subscription, I said, okay, the first step you need to do, you need to create your own virtual machine, and you will use this virtual machine to create all tasks and all labs and so on and so on. But I already pre-configure this virtual machine disk, and I said, okay, you do not need to install all required software like SDK, like IDE and all other stuff. You can just grab my source VHD, and each of you can copy this source file to his private destination and create a virtual machine. And during the last training, when my attendees type this copy command to copy VHD, like it was like 100 gigabyte size, it takes like something from 5 to maximum, I think, like 8 seconds. So it's just 8 seconds to copy 100 gigabyte disk with operational system, with IDE installed, SDK installed, and all other stuff. So it's really kind of very useful command, for example, in this scenario. The next one is snapshot. I think that the main idea of snapshots should be kind of not so hard. Basically, if we want to take like an instant copy of our data, we can use the snapshot mechanism for this stuff. I just want to highlight one point here. When we talk about snapshots and when we talk about like space which will be consumed by this snapshot, I want to say that we will have this snapshot in incremental way. So if we have like 100 gigabyte of data, and when we said we want to have a snapshot of this data, then until this data will change, our snapshot will consume like 0 bytes of additional space. And the last one, called list_blob, the main idea of this operation is that you can have an exclusive access to this blob. I will give another example. I will roll back a little bit to disks. So for example, let's say that we want to attach our virtual disk to our virtual machine. In this case, we need to ensure that only current virtual machine are able to perform some kind of write operations on this blob. So that's why our virtual machine will take this on this VHD file, which is basically like a regular blob. Okay, let's go next. Another very important detail for Azure blobs is metadata. You can work with this metadata in several ways. The first one, you can create a metadata which will be exposed as a regular HTTP headers, like cache control, content encoding, content type, and so on and so on. Here I can give another example. For example, if you go to some websites and if you choose like I want to download some image or some maybe video file, in some sites you will face an issue that you will open like a new tab in the browser, but you said that you will not see this save as window. You will see like an image in your new browser tab, or you will see this video file, and this video file will start like playing in this new tab. But for other websites, when you click like download video, you will see this regular save as window, and you will be able to choose a location on your file system and download this video. So the main difference in this scenario is content type. So basically, if your content type is set to something like application video, then browser will try to play this video inside web browser. If your content type sets something like application stream or some other type, then your browser will try to download this file locally. And of course, you can create your own custom metadata in case you need it, and basically it's just a regular name value pairs. And of course, you can manipulate your metadata independently. It's also kind of very important stuff, because if I want to change only my metadata, I do not want to re-upload the whole blob. I can re-upload just like my metadata stuff, and that's all. Another question, which is almost always came from my training attendees: can we create kind of containers which will have something like regular file system tree or something like this? And the answer is no. You cannot create a container inside another container. So basically, you can consider that your storage account is your root folder, and inside root you can create only containers. So inside root you can create only folders, and inside folders you can create only files. So basically I will answer several questions in this manner. First, we cannot create an inherited containers, and the second one, we cannot upload our blob or create our blob outside the containers. But if we want to emulate this file system tree, we can use slash inside our blob names. But basically, in this scenario, our container name will be like images, and our blob name will be my blobs / blob.jpg. So this slash and this slash is also kind of a part of our blob name. Now let's talk a little bit more about difference between block blobs and page blobs. And the first blob type we will talk about, called block. Let's say that we want to upload our 10 gigabytes movie to cloud. Of course, we can upload this file in like a single request. It will work in case you have a very reliable internet provider. But basically we live not in like ideal world, so that's why it's not a good idea to upload this huge file in a single transaction. That's why what we need to do in this case, we create a blob name. So basically for now we just said, okay, I will have this blob and that's all. Then you need to split your file to some blocks. These blocks can have any size. Basically you can even say that the first blob is 1 megabyte, the second one is 100 megabytes, the third one is, I don't know, 50 megabytes, the next one is 1 gigabyte, and so on and so on. It's not important, so you just create some set of chunks for your original file. And then you start calling put block command. Inside this command you provide like a blob name. In our example it's the blob.vmv. Also you provide a block ID. This is a unique identifier and you need to control this unique identifier by yourself. But it's not kind of an issue because you always can generate, for example, a new GUID and said, okay, here is my unique identifier. And of course you need to provide like a set of bytes or array of bytes which will represent current block or current chunk content. Then put block again and again. Okay, now we upload all our chunks to cloud, and at the end we will just call put block list, and inside this command we need to provide a block name and a list of all our IDs, and those IDs should be in correct order. As you can see in this example, if you want to like join all these chunks in appropriate order, you need to provide this list of IDs also in appropriate order. And this approach gives us several benefits. The first one is efficient continuation and retry, because if you were able to upload like, I don't know, maybe 9 chunks, but you have 10 chunks and one chunk is failed, you can easily re-upload this chunk, and after that you will be able to join all this stuff in the cloud directly. And of course you will have as another benefit, it's parallel and out of order upload, because the only thing you need to do when we talk about order is to provide this block IDs in appropriate order only at the last step. The next one called page blobs, and the main idea of page blobs is that they were optimized for random read and write operations. So you create your blob, but in this case you should say that I will create this blob, and this blob will have up to 10 gigabytes of data. And you will have this fixed page size, and you will be able to start working with your pages. You can set I want to put this page, and yeah, another important stuff here is all this blob basically will be initialized with 0 bytes. So that's why you said put page from this index to that index, and you will be able to upload some data here. After that you can set put page in this way, and of course you will rewrite some data from previous request. You can set clear page, you can put page again, and of course you can get page range, and of course you can get blob. So the main idea of this page blobs is that you are able to talk to each page in this blob. So basically you will have like two different scenarios, and my recommendation will be like this one. Always try to use block blobs. If in some case you are unable to use block blobs or you will have not really kind of a good user experience or developer experience working with block blobs, only after that try to work with page blobs, because working with page blobs it always is a little bit kind of harder than working with block blobs. The next important stuff is shared access signatures. When we talk about Azure Blob Storage, you always have like two master keys. They are completely independent, but basically it's just two keys with maximum permission level for the whole storage account. But let's say that you want to provide user with an interesting feature. For example, you create some kind of social app and you said my users are able to upload like avatars or something like this directly to blob storage. So why not? Because blob storage it's just a REST service, so you can easily talk to REST service from any platform which can communicate using HTTP protocol. Okay, but as you may understand, it's very insecure to provide your end users with access key with like a full admin permissions to the whole service. So that's why you can set, okay, I will provide my users with shared access signatures. And the main idea of this shared access signatures is to create a kind of URL which will work on the limited amount of time and which will override the default access rules. And of course you have two types, ad hoc and policy based. And now I will describe the difference. The first one is ad hoc signatures. The main idea of these signatures is that you can issue this signature for blob or container, so you can choose the level of these permissions. And also you need to provide access policy start time and access policy expiration time. The last one, you need to provide permissions. For permissions, you have three options: read, write, and delete. And basically, you can mix them in any combination. For example, you can set, I want to provide for this user only write and I don't know, and delete permissions. In that case, user will be able to upload this file to Blob and delete this file from Blob, but basically he will be unable to read this file from this Blob using your current signature. So you provide resource in this argument. We have C letter here, so it's container. This argument displaying start time for our shared access signature, and this argument shows us an expiration time. Here we have permissions. So basically this URL will be generated only for write permissions. And here we will have the same arguments, but these arguments was like encrypted with our master key. So that's why when our server will grab this request, he will decrypt this signature and compare it to first four arguments. In case they match, we will have all required access level. But in case they will not match, server will say, sorry bro, you are unable to access this blob. And in this case, we will have one disadvantage, but I will describe this disadvantage using the next slide. So, the second kind of signatures called policy-based signatures. In this case, you create a policy, and as you can see here, you provide not the exact permissions, but you provide like a link to your policy. But basically all other stuff will work the same. The only one difference, as I said, in ad hoc shared access signature, it's kind of disadvantage. If you create policy-based signature, you can easily revoke all permissions. You can change this policy permissions on your server side, and after that every request will go and read this policy permissions from the server, and in case you will change it on the server, it will automatically affect all subsequent requests. But when we talk about ad hoc signature, in case you're, accidentally provide user with more high-level permissions, then you will be unable to revoke this signature in any way. So also you need to think about this stuff. Okay, now let's talk a little bit about CDN. The main idea of CDN is to deliver your static content, and you can store this static content much more closer to end user. So let's say that you have an Azure storage account called images. For this account, you can request a CDN endpoint. And basically, Microsoft will generate some kind of random endpoint ID for this storage account. And of course, you will be able to provide your custom DNS name for both storage account and CDN. So let's say that you already configure all this DNS stuff and you want to start using your CDN. Here is a quick diagram and I will illustrate how CDN will work in this case. Basically, you have this Azure storage in like a single data center located, I don't know, maybe somewhere in Ireland. Okay, cool. But let's say that you have some users from Germany, from France, and for example, I don't know, from England. Okay, from England it's not kind of a big deal to download files stored in Ireland, but from like German guy's perspective or from the French guy's perspective, it's not like closest road to this data center in Ireland. So that's why you can use these edge nodes for your static content. And let's say that you generate this URL for your user. So basically you generate a regular HTML page, but for, I don't know, maybe your website logo or user avatar, you generate this URL. What is interesting in this URL? The entire domain name, like guid01 vo msecdn.net, it's a domain name of your CDN endpoint, and Microsoft will understand and Microsoft will be able to recognize to which storage account he should map this URL. And then you have a regular container name, images, and pick one.jpg as your file name. And let's say that your user call for this image. He will call the closest edge location. Why? Because Microsoft will try to map exact user location with like closest CDN node. You do not need to pay attention on this magic. Let's say that it's just kind of a big black box and you work with this black box without digging inside. And Microsoft will map, as I said, this CDN name to storage account name, and from this edge location Microsoft will send a request to your blob storage and cache this file on edge location. And Microsoft will cache this file here for some limited amount of time, and you are able to configure this detail parameter, and this file will be returned to the user from edge location, not from like original storage, but user will obtain a cached copy. Let's say that second user also request for this file. If our detail is not expired yet, we will return this file back to this user without calling our main location. Also, I want to highlight one point. For example, let's say that we said that we want to cache this picture on CDN nodes for like 60 seconds, so for 1 minute. This 1 minute will not have like a sliding expiration way of working, because in that case it will be really kind of funny. If you have a high load application, you will be unable to refresh your cache. So basically, when you put this file to your cache and said, please host this file for 1 minute, after 1 minute from the first request, this file will be automatically deleted from edge location. So our TTL is expired and our file was deleted. The next user call for this file, and again we will grab this file from our main location. Let's say that we remove this file from main location. In that case, if user will call for this file and if TTL is not expired, we will return this file back to the user from our cache node. And of course, well, TTL expires and we will call for this file, we will return just 404 error and said, sorry, we are unable to find this file. So it's just a regular way in which each CDN engine works. Now let's talk a little bit about Azure Table Storage. When we talk about Azure Table Storage, we will have almost the same structure as we have for Blob Storage. We also have our storage account. Inside our storage account, we will have different tables, and inside our tables, we will have our entities. Okay, for now it's clear. The most important part here, as I already said, when we talk about Azure Tables, it's not a relational database management system. It's just a key-value storage. It's very important. You can create, query, and delete your tables. And when we talk about your entities, you can insert, update. You have different strategies for update, merge, or replace. You can upsert, so it's basically insert or update, delete, and query, of course. And also you can perform some kind of batch operations if you do not want to work for each operation independently, and if you want to speed up your application a little bit, you can work in this batch manner. Okay, let's try to find out what we have from the entity perspective in these tables. So it's key-value storage, but it's structured storage. That's why your entity can have a custom properties. And your entity with all properties can take or can consume up to 1 megabytes per entity. Of course, Microsoft will say that they create some kind of mandatory properties. The first two mandatory properties called partition key and row key, and these two properties they are represents just as strings in your storage, and this is the only two properties which have index. And of course, this index defines the sort order, because you are unable to sort your entities on a Azure table service level. If you want to sort them, you can only grab them to your color and, for example, to your web service, and said, okay, please sort these entities in this order. And of course, this partition key and row key should be unique. And the next one, mandatory field called timestamp. Basically, this timestamp stands for solving optimistic concurrency tasks. When we talk about optimistic concurrency, the main idea we have here is, let's say that we have, like, I don't know, 10 concurrent transactions which came to our service literally at the same time. In this case, let's say that we want to update the same record with 10 different transactions. In this case, Azure will try to find this entity in table, not by these two keys like partition key and row key, but it will try to find it using three keys: partition key, row key, and timestamp. The first request will find this record and it will update this record. After that, automatically timestamp will be auto-incremented by the Azure table service itself. So that's why all subsequent requests with an old timestamp will be unable to find this record, and that's why you will have like an exception on the client side, and on the client side you will obtain something like, sorry, we are unable to find the exact record. And also another interesting point, that for all records inside your tables you have no fixed schema. Let's go to the next slide, and as you see here, we have just a simple table. We have first name, last name, and birth date, but here you have this birth date in completely different format. From the Azure table perspective, it's okay. It's really not okay from like database or storage perspective, because it's really kind of hard to work with this kind of data, but you need to know about this point, and you need also to manage this stuff in your application. And of course, if you want to add like favorites port for Netan, for example, you can create this field here, like create this column here, but all other entities, all other rows will have just null for favorite port. Let's talk a little bit about querying our tables. Of course, we have a nice looking SDK for Node.js, but let's say that you want to create like a bare HTTP request. In this case, you will work in a manner how you work with a regular OData protocol. So you just set filter, field name, then compare expression, and then value. So basically, I want to filter all last names equal to Wagner, something like this, and I will obtain only this record as a result set. The main idea of partition key is to create kind of scalable storage. Because when we talk about cloud, one of the three main points is kind of scalability. So in case I have only like 3 records in my table, it will work fast. Okay, it's not an issue, it's not a question, it's obvious. But let's say that I will have something like 10 million records inside one table. It's kind of common scenario for Azure table storage to have not maybe even 10 millions, but let's say 10 billions of records inside the same table. So it's not an issue, but Microsoft will always try to provide you with like a most good experience, or with as much good experience as Microsoft can, also from the performance perspective. So that's why Microsoft said that they will use this partition key to split your data inside your table between several partitions. And all partition will be saved in the same location, but different partitions can be saved in different locations. That's why we have this limitation when we create a batch transaction, when we create kind of several requests and want to execute them at the same time. We can achieve this goal only if all these requests affect a single partition. And from the performance perspective, Microsoft will try to provide us with experience like 500 requests per partition. So it's kind of very good performance, by the way. And I want just to illustrate this partition stuff here on this small example. So let's say that we have all our records on a single server, but let's say that we faced an issue, like a performance issue, and Microsoft will notice this, and Microsoft will automatically split our table between several logical servers. The main idea here is that we will not see this from the outside world, and we will be not affected by this from the outside world. So we will have just like a regular connection string to our storage account. We will have like only single endpoint for accessing our storage account, but underneath Microsoft can host all our table data in like completely different servers. So it's not a problem for us, but from Microsoft perspective, Microsoft will try to provide us with as much good experience as he can.